Hello everyone, once again welcome back to the DSA with Daksh series. Myself Daksh Patel, and today we're gonna solve question number 1684 of Leetcode. Count the number of consistent strings. Okay, and this is the DSA series where you can find the problem solving according to interview level. It will help to improve your approach building and logical thinking. Okay, so one thing you have to stay consistent to master DSA. Okay, and try to do question by your approach and think about it. Okay, and as much possible as you have to try about logic, how this logic gonna work and what was should be as possible. Okay, and yesterday we saw a question which question number 1752, like check if array is sorted and rotated. Okay, where we are checking that the current array is at the starting point is sorted, and after that it's rotated in some a order of x. Okay, so if you does not watch yesterday's video, you can check out the video link in I button. Okay, and now we move to the today's question. First, I'll explain question, then after we move to the example parts, and after we discuss about the all possible approaches, and lastly we will write a code for that and discuss its time and space complexity. So first the question is given. You are given a string, okay, of allowed. A question given to you a string of allowed. Consider of distinct characters. Okay, the characters contained in a given string is all are a different. Okay, and an array of strings. Okay, one more thing is given you, an array of strings words, the array names of words. A string is consistent if all characters in the string appears in the string allowed. Okay, in the words array as multiple strings. Okay, if a string is consistent if all character in the string appears in the string allowed. Okay, the array contains different strings. If one string contains all word of which is belongs to allowed, so it means it's consistent. Okay, return the number of consistent string in the array of words. Okay, you have to return number of strings which is consistent present in words array. Okay, we'll see example one, so you got clear about better. So first they given you input allowed. Okay, so allowed string is AB. Now you have to find word which is made up only of this AB character. Okay, repetitions is allowed, but the word should be contained AB. So first word is AD, so it's not. Afterward is BD, it's also not. Okay, the second index word is AAB. So yes, it's consistent word. You can count one. And third word is also BAA. It's also, but this is B8, the one D is there, so it's not consistent. So there is two consistent words. Okay, so output is true. Okay, you can read out the explanations. Okay, there are two more examples given. If you have to read, you can read. The length of the words is between 1 to 10 to the power 4. Okay, the length of words array is between 1 to 10 to the power 4, and the allowed length. Okay, allowed is the like contains words the string which is stores the characters. Okay, and it store only unique characters. So the length of allowed is between 1 to 26, because it will maximum only contains whole like A to Z characters. Okay, and the words I. Okay, each word. Okay, each like string stored inside words array, its length between 1 to 10. Okay, the characters in allowed are distinct. Okay, they are mentioned here also. Okay, the words of I and allowed contains only lowercase letter. Okay, the words of I and allowed, okay, contains only lowercase English letter, so it will help you because you does not have to worry about the special character and uppercase letters and outside of the English letters. Okay, it only contains lowercase English letters, so you have to write one approach and it's a simpler for you. Okay, so this is the question. So now we'll move to the approaches part. Okay, so let we discuss about all possible approaches. So here in this video we're gonna solve by this question by two approaches. Okay, first approach we use one for loop and inside one another for loop. One for loop for iterating our whole words array, and another for loop for iterating in each word. Okay, each word means each string inside the words array stored, so iterating in that strings. Okay, so and we take one count variable and like it's a comparison between allowed and the inside string stored in words array. So this is the first approach for us. Okay, one more approach we gonna do is, okay, we use set of inbuilt functions, like first use, like we declare new set, okay, and after that we use filter to filter out words, okay, then use one more new inbuilt function into, okay, to every and as character, okay. So it will basically find each and every character from our given string and return that count of it. Okay, so this is the two approach we will discuss in here. Okay, and if you find any new approach you can try by that also. So I'll start with the first approach. Let count equal to 0. Okay, for let I, wait, let word of words, we have to iterating in words, not from I. So we use word of words. Word is basically each and every string stored inside the words, and words is the array. Okay, if wait, let, okay, is consistent, okay, starting using true, yes, it's consistent, okay. So for let character of word, okay, now we moving from character of words, okay, if it's allowed, it's not allowed, okay, I'll already use not, okay, not operator, okay, if it's not allowed, I think something, if it's not allowed, okay, in this, so for that part we use is consistent becomes false, okay, okay, and then we break this inside loop, okay. Now if these conditions does not appear in any time, so it means that this is consistent. So for that, if it is consistent count plus plus, like it's only made up of our given allowed array, so we'll increase count one, count plus plus of it, and return count value, okay. So we'll run this, okay, to check whether each and everything is perfect or not. Okay, it's showing our, okay, here we, okay, now I run one more time. Okay, you can see that our answer is accepted. Okay, all given three examples test cases are passed. Now we'll submit it for further lead code test cases, like it's given a set of test cases. So the question is basically whether the given thing, okay, is like you have to iterating in both way. First is from their array of words, and another iteration is in inbuilt, like given strings of words array, okay. So like answer is judging, let us wait. So you can see that our answer is accepted, okay. So each and every test cases are passed. Now we move to the second approach, okay. Okay, so now we'll start our second approach. Firstly, I'll remove this whole thing. So for second approach, first we declare one allowed set, okay, new set of, okay, you can use it directly, but I am declaring it as a set. Now directly do each and everything and return word dot filter. We're filtering our words array with like word, okay, word of it. So we use first spread operator to count the whole our array, like whole string, okay. Now use one inbuilt function every. Okay, so it will applicable for each and every. So what we want, character of our whole string, so we use character of it. Now character, now we'll check in our allowed set. Okay, to has it to character. Okay, now we have, it will check it. If it's allowed, it's gonna move to the forward. But in case of this is allowed, we what we have to do is we have to take its length. Okay, so we will use take its length. Okay, how many times it will perfect. So it's like as a count. Okay, stores count. So now I'll run whether it is correct or not to check. Okay, so we'll just do same thing as the our above, but will totally depends upon inbuilt function for this approach. So you can see that our answer is accepted. All three examples test cases are passed. Now we'll submit for further lead code test cases. So it will like checking it. So the answer is, you can check out that answer is accepted. All 74 test cases are passed. Okay. So now we'll move to the our time and space complexity part for this. Okay. So our first approach is there with the using of one for loop inside another for loop. Okay. And one variable of let count and another is consistent variable. Okay. So for that approach, our like time complexity is order of n into m. Okay, where n is the number of words. Words means number of words, uh, like this array's length. Okay, words array's length, and the m is average word length. Okay, each string stored in our words array, the average of that string is stored in m. So the time complexity becomes what, that is order of n into m. Okay, and our space complexity is order of 1 for our first approach. Okay, for second approach, our time complexity becomes order of n into m. It's same. Okay, time complexity should be same. We using multiple things, but it's same. We firstly use words array, and we'll take a from words array and finding its each and every character. So it's already order of n into m. Now our space complexity here becomes order of k because we using new set, allowed set. Okay, and k is the length of allowed words. Okay, so the space complexity for this approach is order of k and time complexity is order of n into m, where our spread operators like the time complexity is order of m and filter is order dot filter inbuilt functions time complexity is order of n. Okay, and set dot has time complexity is order of 1, so it won't get matter. So one is order of n and another is order of n, so it's order of n into m. I hope you got clear about these questions, time and space complexity. Okay, and if you find any doubts about today's video, you can ask me in comment section. Okay, and this is the like two approach. Okay, first and second approach. You have any other approach in mind, you can try this question by your approach. Okay, and let me know in comment section you will done this question by which approach. Okay, now we'll move to the tomorrow's question part. Okay, so now I'll open the tomorrow's question. So we'll see tomorrow's question at that. It's 1832 question. Like check if given, okay, sentence is pentagram or not. Okay, it's simpler question. A pentagram sentence where every letters of English alphabet appears at least once. Okay, you know what is pentagram. Give a string sentence containing only lowercase English letters. Okay, return true if a sentence is a pentagram or false otherwise. Okay, if the given sentence is not pentagram, you can return false. If it's pentagram, you have to return true. You have to just check it. You can see the example on each and every character is unique, so you can return true. In lead code, it's false because E is repeating twice. Okay, sorry, twice. We'll see the condition for that question. One condition is given to you, the length of the sentence is between 1 to 1000. Okay, so there is much more cases which is not pentagram. Okay, and the sentence consists of only lowercase English letters. Okay, so this question is simpler where you only use lowercase English letters. You can do it without any efforts. Okay, so I hope you can solve this question. Okay, and after completing this question, you have to post it on LinkedIn and Twitter. Mention me. Okay, and you have to try this question by multiple approaches. I know that you can do this question as much as possible approaches. Okay, so thanks for the watching this video, and if you find any doubts about this video and questions or any video other video, you can ask me in comment section of that video. Okay, I'll try to resolve your doubts. And for code, can check out our GitHub repo where each and every code and explanation updated with the approaches in C, C++, and JS in 3 languages. Okay, so you can check out that. Okay, and if you not started yet DSA with the series, you can start it from day one. Link in I button. Where in day one video I'll explain each and everything about this series. Okay, so you can start learning of DSA from absolute beginner. Okay, so DSA is important for your technical skills and for interviews. Okay, so you have to master problem solving. Okay, so I hope you can start DSA and master DSA. Okay, and as well as if you have any doubts, you can ask me in comments. And thanks for watching the video. And if you don't solve this question, don't worry, we're gonna solve this question in tomorrow's video. You can check out that video tomorrow. And in that video, firstly you can see the approaches, and you can try to code by yourself. And if doesn't code work, you can come and check out after that code, and you can write code after that. Okay, so thanks for watching the video. Meet on tomorrow's video.